All right, so let's get started. Good morning, everybody. Morning. Hello. Nice to see you all back here with electricity. It's great. Very good. Okay, so welcome to From Protocols to Performance. My name's Tom Barthel-Steer. I'm going to be teaching you this class today. One reminder before we get started, this is an ETCP accredited class, so if you're working on ETCP points, come and see me afterwards, sign the sheet, and we'll get you going. So I am ETC's Technical Product Manager for Network and Power Products. I wrote a program called SISN View, which we're going to be taking a look at in a little bit as one of the many diagnostic tools you can use for networking. And previously I was a field service engineer. I worked as a theater manager, technical manager, and a variety of other things. So what we're going to cover today is, initially this was going to be the start of our discussions about networking. Now I'm going to kind of wrap up our discussions about networking. So we're going to cover a little bit of the history of why networking in entertainment systems works the way it does today. We're going to look at things that you can do right now with integration. What we're going to do is we're going to dig a little deeper into what we saw with Jason and Nick and Jake yesterday. And I'm going to show you some tools for setting up and diagnosing that kind of integration if you want to do it. And then we're going to talk about what you can do, what you can't do, and what's coming in the future. So let's go way back to the 70s. Who remembers analog control? Who's worked with analog control? Yeah, quite a lot of people. So way back in the 70s, we wanted to control dimmers. It was all about dimmers. And so we used what was called 0 to 10 volt control, which meant you had one wire for each dimmer, and the voltage on that wire told you how bright the dimmer was. If the voltage was 10 volts, it was full. If the voltage was 5 volts, it was at 50% brightness. And if the voltage was 0, the dimmer was off. So you can see a picture here of the back of a console from that kind of era. You had lots and lots of connections on the back of it. And this was not really a very good idea when you had lots of dimmers. It meant you had a lot of wires to deal with. They were very fragile. They broke very easily. It also wasn't well standardized. Everybody had a different way of doing it, a different connector, a different voltage range they used. It was pretty painful. So there was really a need for a better way to do control of lighting. So a variety of things were tried, again, by different companies. They were generally proprietary. And then we ended up with DMX. So DMX 512, it's called DMX 512 because you control 512 addresses, 512 dimmers at the start, over one piece of cable. Great, so we've gone from these big fragile cables with lots and lots of connections to one cable with a standard way of doing things. And the way standards in our industry work is they're managed by a combination of Esther in the US and Plaza in Europe, and they're publicly available. So if you ever fancy some good bedtime reading and you want to read the exact standard of how DMX works, you can actually go to the Esther Technical Standards Project page, and you can download all of these standards from there. So anything I'm talking about today, if you're interested in learning more about it, you can go there. And the neat thing about that is that all manufacturers can read and agree on those protocols, and they're designed and agreed upon by a group of manufacturers working together. So it's not ETC going off and doing our thing and Strand going and doing their thing. We've all got together and agreed this is the way the control is going to work. So back when this first started happening, we first started using DMX. It was really simple. I'm sure we've all put lots of systems together like this one. It's great. You have one controller, one thing that's doing the controlling. In this case, it's a smart fade. You have multiple devices being controlled. So say we've got 3 dimmer racks. And then you terminate the line at the end. Who knows why we terminate DMX at the end? Doesn't bounce back. Yep, that's right. You can kind of think of electrical signals in a cable kind of like a wave. And what the terminator does is provides a nice end so the wave stops there rather than hitting the end and bouncing back again. That's called a reflection, and it can lead to weird signaling problems. So always terminate your DMX line. So that was all well and good with dimmers. And then around the 80s, we started getting into moving lights. So now we've got additional things which are in different places to the dimmers, right? The dimmers are usually behind the stage or in a dimmer room somewhere. The moving lights are over the stage. So now we need our data in more than one place. We need data for the moving lights and we need data for the dimmers. So we started doing things a bit more like this. So now we've got multiple lines of DMX coming from the controller. It's got multiple outputs. You might have one going to some moving lights, one going to some LEDs, and one going to some dimmers. And now 512 channels was not enough anymore. Initially, talking to the people who designed DMX in the early days, they really picked 512 because they thought, well, nobody will ever need more than 512 dimmers. Which is maybe true, but with moving lights and things like that, you need a lot more. So then we started using multiple universes. So the interesting thing about that is the thing that defines the universe, when you think about it, is what ports it's plugged into on the console. So, you know, for example, my dimmer racks might be plugged into port 1, my moving lights might be plugged into port 2. But those dimmer racks or moving lights don't really know that they're in that universe. It's defined by the cabling. That's something really important to remember when we get into network systems. So about the same kind of time, the sort of early 80s, computer networking was beginning to be a thing. Computers had come down in price. Offices had more than one computer and they wanted to join them together so that they could share data, share files between their computers. So this is a very early version of Ethernet. This is what was called ThickNet. Has anybody worked with this? This is a real age test. All right, one more elderly gentleman at the back there. So this stuff was pretty painful to work with. The way it worked is it was a large, chunky cable that essentially ran in a loop. And then these things were called vampire taps because they have little teeth and you tighten them down onto the cable and the teeth pierce into the cable to make the connection. So you have one of those at each computer. It was pretty janky, pretty difficult to work with. So there were some obvious parallels going on here. In the IoT industry, they wanted to get lots of data around the place. In the lighting industry, we wanted to get lots of data around the place, and we were beginning to run into the limits of DMX. So in the 1990s, ETC was one of the first companies to start using computer networking for lighting. So we started out with what was just called ETC Net back then, or EDC Net1. Which was a totally proprietary system. And it didn't do very much. All it really did was we'd realized, okay, we have the back of the console and we have multiple DMX ports and we have monitor outputs and focus units and stuff like that. It would be really handy to have those somewhere else and just have to run one cable between the two. So that's really all that ETC Net1 did. It gave you one cable that you could remote the back of your desk to somewhere else. Had some limitations. So then later on we came out with ETC Net2, which allowed you to do a lot more, had a lot more flexibility, but it was still proprietary. We did it ourselves and we didn't tell anybody else how we did it. So let's jump and talk about cabling for a little bit. And for all of you who were in the room yesterday, we mentioned a little on cabling there too. You got some practice at termination. So everybody calls it a piece of Cat5 cable, but really it's Cat5e or better these days, Cat6 or Cat7. And we all did some testing and certification yesterday. So we plugged in our testers, we found the faults in our cable. And as I mentioned yesterday, this is super important. If you are doing networking in your facility, whether you're doing it yourself, whether you're having a contractor do this work for you, make sure your cables are tested properly with a certification tester, because that guarantees they're going to keep working through the show. I've seen flaky, intermittent behavior where it sometimes works, sometimes doesn't, and as you all know, the time that it's not going to work is the time you really need it to work. So moving on to today, things have got better. Things are a lot more standardized because in the early days there was ETC Net2, there was Strands Lighting Network Protocol. Again, everybody was kind of doing their own thing without standardization. So now there are two major protocols in use for control of the lights, getting data from your desk to the lights. And those are streaming ACN and Artnet. There are a few technical reasons why streaming ACN is slightly better. Artnet is perfectly fine for a lot of cases. And actually, the latest version of Artnet kind of includes streaming ACN. It says, hey, you can just use streaming ACN as well. So streaming ACN is doing pretty well at being the control protocol that's used for getting control from the desk to the lights. And it's pretty simple. It's a lot like DMX over Ethernet. And we'll talk in a second about some of the funny things you run into with DMX over Ethernet. So that's pretty good. We've got control. It's working. Feedback. We have ACN. So ACN, to steal a phrase from Steve Terry, is a party we threw that nobody came to. We did a lot of work on the ACN standard. It's a large and complex standard. And because it's so large and complex, it hasn't really been widely used. So I'll talk in a little bit about some of the directions we're going and hopefully getting some more integration in the other directions.
What does it stand for?
ACN stands for Architecture for Control Networks. Sounds fancy. And then there's some other stuff on the network. There are still some things that are proprietary. For example, the way that a Paradigm touchscreen talks back to the Paradigm processor. That's all our own products, so we don't really publish how that works. That's just kind of our own thing. And then we have some of the integration protocols, some of the things that Jason was showing you yesterday, things like OSC, UDP Strings. And we're going to dig a little bit more into those and kind of see some more guts of how they work. So we haven't gone a whole lot into the depths of how a network works in these classes, and I think that's okay because there's some really good videos on YouTube if you want to educate yourself on these things. But for some of the stuff I'm about to show you, it helps to have a couple of basic concepts. So one of them is the ways that you can communicate on a network. And there's broadly 3 ways on a modern Ethernet network. There's 3 kinds of communication going on. There's unicast communication. So let me demonstrate a unicast communication to you. Good morning, Dawn. How are you today?
Hi, Tom. I'm good.
Excellent. That was a unicast communication. I was talking to Dawn. Dawn was talking back to me, one-to-one. So we can also do multicast. So multicast is talking to a group. So if I was to say, hey, everybody in the front row, how are you doing today?
Very good.
Very good. All right, so that was a multicast communication. I picked a group of you, and I talked to you. And then the final method is broadcast. So if I say, hey, everybody, how are you doing today? Very good. So that was broadcast. Everybody in the room gets to talk. One thing you will have noticed that can become important is the unicast communication is much easier to understand when you're talking back because there's only one person talking at a time, one-to-one. When you get one-to-many or many-to-many, it gets more difficult to talk. Same thing on the network. All right, so let's talk now about streaming ACN. So who here works in a facility that has network and uses streaming ACN regularly? Most people. All right, cool. So DMX was pretty simple. As I said, we had one console, one controller. It had multiple universes coming out, and remember the universe is really just defined by which cable that plugs into the port. And then we had the receiving devices on the end who were just listening. So all that tells you the universe is the wire. But now, on the back of my console, I've got one Ethernet port, but it's sending out multiple universes. So the wire doesn't really tell me anything. The wire is just going to the console, and then it's going to some gateways. So with streaming ACN, you've got multiple universes which are identified by a universe number. So this is kind of the same thing we used to do with DMX. We'd have a tape on the piece of cable. We'd say, okay, this is universe 1, it's going to the dimmers. This is universe 2, that's going to the lights. Same conceptual thing, but it's all inside that Ethernet wire, if you like. So we can also now have multiple controllers. With DMX, there is only ever one controlling device. Has anybody ever plugged 2 controlling devices into a DMX line? No? It's really exciting when you try it. Because essentially they're both sending electrical data at the same time. They're out of sync, so there's just junk appearing on the line, and everything will start flashing on and off. You'll see some really, really exciting effects if you ever try that. So we dealt with that on the network side by introducing this concept of priority. So very often in a real system, you want things to have priorities. You want to say, okay, when the console is not running, I want my Paradigm system to be able to control the lights, so I can fade the house lights up and down. But then when I plug my console in, I want that to take over, to take control, and to be the only thing that's able to talk. So that's done in streaming ACN with a number called priority. And our priority ranges from 200, which is the highest priority, the most strongest, going to take control, to 1, which is the lowest, weakest priority. It's going to give up control to anything. So 100 is in the middle. Most of everything that you take out of the box will default to a priority of 100, and then you can set it up there. So for example, in EOS, you can go into the shell and you can configure what priority you want that EOS console to send data at. So this, in the standard way of doing things, all happens on a per universe basis. So I can say, okay, my console is going to send data to universe 1 at priority 100. And then you can very often set different priorities for different universes. So I can say, okay, in universe 2, I'm going to set some kind of lower priority for whatever reason. When priorities match, when they're the same, so if I have my paradigm system and my EOS console both sending data at the same priority, they will merge. The highest level will take precedence. Got a question over there?
In a multi-console setup, and you have users, is that still the same priority, or is that answer?
So the question was, in a multi-console setup, when you have users, is that the same priority?
User 1 and user 2, is that the same thing as priority?
No. So I will put the caveat that I am not an expert on EOS multi-console setups, and Nick is coming in a little bit to talk about those. So he will definitely know this answer. But those different users, it's more to do with who is accessing the console to do data entry into the console rather than the data that's coming out of the console to go to the wires. Does that kind of answer your question?
Yes.
Cool, good. Very good. So as I was saying, this priority is on a per universe basis in the standard. But there are situations where that isn't really granular enough. So there is an ETC extension to this standard called per address priority. So now rather than just sending priority for the whole universe, we can go in and noodle the priority for the individual addresses. We can say, okay, the house lights, I want to be able to control from the paradigm system at a higher priority, so I can always grab control of those. But my snapshot looks that I've taken of the stage should be lower priority, so they don't accidentally do anything when the console is on during the show. So something to be aware of is that is an ETC extension to the standard. We have told other manufacturers about it, but not many other people have implemented it. So if you're mixing ETC gear with other people's gear and you're seeing kind of some strange effects within a universe, that's something to look out for, is it might be related to mixing per universe and per address properties. Okay, so, all right, this sounds really great and sounds like I can make a really complicated system and get myself into trouble. How do I figure out what's going on? So I'm going to show you a program called SISN View. This is a program that I wrote, and it's a pretty useful tool, without blowing my own horn too much, for diagnosing what's going on a network. So let's take a look at it right now. I'm going to switch to there. There we go. Okay, so this is what SISN View looks like. It's a free application. You can download it from that website I just showed, and you will be getting a copy of this PowerPoint, so you'll have all these links and things that I'm showing you. This is what the application looks like. So it can both receive and send streaming ACN. So when you start the program up, you'll see on the left-hand side, I have a list of universes. So like I said, multiple universes all coming down that one cable to my laptop. And I can see I'm looking at the first 18 universes here, out of 64,999 is the maximum universe number. So that'll be enough universes forever, right? We're beginning to run out again. So I can see I've got one thing that's sending data at the moment, which is an RPU. So, all right, now I want to drill into this universe of DMX that it's sending and see what we've got going on. So I can double-click right here. And here I can see the levels. So my setup here is I've got an RPU that's sitting there, right there. And you can see a little blue LED panel over there. That's actually a DMX monitor that's showing the live output from the network. So if I have a gateway there set up on universe 1, that's showing me what's going on universe 1. So now I can see my levels here, and I can see that they match what's happening on the output. And I can pick any particular address, make this bit bigger, and see why it's at the level it's at. So this is address 44. It's at level 85, and it's being controlled by that RPU at priority 100. I can also send levels from here. So the red buttons, red for danger, click to send. So I'm going to send some data on universe 1, and let me show you how priorities work. So instead of sending at priority 100, I'm going to change this to priority 150. I'm going to start sending some data, and you will see that the blue LEDs on my panel have now gone off. And if I go back to my universe view, you can see why that is that my SISN view is now sending levels at 0 with a priority of 150. So it's got a higher priority, so it's winning. If I now make that, let's send a fade, something like that. So now we can see our levels are all fading up and down over there. And again, we can see that fade happening in real time on the display here. So if you have weird stuff going on in your network, you're not sure what's happening with DMX control, this is the first step. It's fire up a tool like this, take a look at what's going on. The really nice thing about this, because it can send and receive, is that you can actually sit at home with your PC without any kind of lighting stuff connected, and you can see what's going to happen in a particular scenario. So if you're wondering, hey, what happens if I send this, streaming ACN value with this priority and this, you can try it at home. You can look at it right in the application and see what's going on. So pretty helpful tool. So that's streaming ACN view. There's a lot of other features in there. I won't go into detail on each and every one. There's some documentation on the website. But any questions about streaming ACN and DMX control? Because that's really the bread and butter of what we do. That's the most likely thing you're going to do every day with a network system. So it's really helpful to know how to troubleshoot this. So any questions about this part of things? Yes? Mm-hmm. Yeah, so the question was, is streaming ACN available in every console? And the answer is pretty much yes at this point. I have not seen any networked consoles for quite some time that don't do streaming ACN. So, yeah.
We have tried to mix cobalt and an ion, and it doesn't work.
You tried to mix a cobalt and an ion, it doesn't work. Yeah, I'm not quite sure what's going on there, because it's... It could be, like I said, my first step there would be if you're trying to connect your cobalt and your ion at the same time and something's not working, I would fire up streaming ACN view, and you should be able to see both of them and to see what priorities. So if maybe one is set to a higher priority, you'd be able to look at that channel data and see, oh, this is sending higher priority, that's what's going on. So yeah, really as a first step to troubleshooting anything like that, a tool like this can really help you out. Another question?
So you referred to this protocol as both ACN and streaming ACN. Are they the same? Are they different?
Good question. So the question was, I've mentioned both ACN and streaming ACN. So ACN was an initial kind of grand vision of a protocol that did everything. It was going to give you feedback from your lights and dimmers. It was going to control them. It was going to do all kinds of magical things. So it ended up being very large, very complex. And so it had acceptance problems. Nobody really did it. So we said, okay, we're going to really strip it down, and we're going to use some of the same techniques that was using in terms of transporting data, but we're just going to do basically DMX over the network to really simplify it. So that's what streaming ACN is. It still uses some of the data structures and things from ACN, but it really crunches it down to just the most basic thing you need to do, which is get DMX around the network. Does that kind of answer your question? Good. All right, any other streaming ACN questions? Yes? Does SISN support RDM? No, it does not. SISN is purely about DMX-style levels over a network. There is some work going on in RDM, which I'm going to talk about in a little bit, and that's something we're working towards, so stay tuned. All right, anything else streaming control related? No, good, great. So, all right, so streaming ACN view gives you a really nice, kind of fairly friendly view of what's going on the network. But sometimes you need a little more detail. So sometimes you have to delve right into the depths of what's going on. And there is an industry standard tool used for doing that, which is called Wireshark. People often get a little bit scared when we start getting into Wireshark. Don't be scared. I'm going to show you some of the basics of how it works. It's really not as scary as it sounds. But there are a few things it's good to know before you start using Wireshark. Otherwise, you're going to see a whole lot of stuff on the screen that doesn't really make any sense. One is base 16 or hexadecimal. And we've actually used some of this. We mentioned a couple of values yesterday. We said things like RDM starts with CC. Well, what does that mean? So we're all human beings, hopefully. Yes. So we count in base 10. The only reason we do that is that we've got 10 fingers. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we get to 10, which is kind of a special case because the first digit resets to 0, and then the second digit is going to 1. But there's no particular reason you have to do that. Computers, fundamentally by their nature, they use digital signals, which are on or off. So computers really count in binary, 1 and 0. But that's a really inconvenient way to write down large numbers. So a lot of computer-related stuff, engineering-related stuff, you will see in base 16, which is hexadecimal. So what that means is instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I have some additional digits, which I call A, B, C, D, E, F. So F is 16. And then I go to 1, 0, which means 17 in hex. So that's hexadecimal. You'll see a lot of that in Wireshark. You don't necessarily have to understand all of it, but that's what a lot of the scary-looking stuff is. The other thing you'll run into is TCP and UDP, and this is related to those conversations that we were having earlier. So TCP is kind of like the conversation I had with Dawn. I started the conversation, I got a reply, I sent some stuff, she sent some stuff. It's a back and forth conversation. So that's great, and that works really well for one-to-one. It's really difficult to do that with multiple people at the same time. I've been to some parties where that's been terribly difficult. So UDP, or the unsigned datagram protocol, is more, I'm going to shout something out. Somebody might get it, they might not get it. So a lot of the things that we're using in streaming ACN, for example, you can imagine if I had a console sending data and I had to send each of my gateways in the system that data and then get a reply to carry on that conversation, that would be a lot of conversations to be having at once with the 200, 300 gateways in my system. So we just use UDP. We send the message out. It might get there, it might not get there. The nice thing about these streaming protocols is if it doesn't get there, there'll be another one in a minute. DMX actually works the same way. There's no reply in DMX. There's no guarantee that it got there because we're just going to send those 512 channels over and over again. So if one chunk gets lost, doesn't really matter. There'll be another one in a minute. And multicasting. So we had a bit of a multicast conversation earlier where I talked to the front row. Multicasting is heavily, heavily used in our stuff because, again, I'm trying to address 200 gateways and send them all universe 1. I don't want to do it discretely to all of them, but I also don't want to send data that they don't need. So we use a lot of multicasting to get the right data to the right group of devices. So we're going to take a look now at Wireshark. So Wireshark, again, it's a free application. You can download that from the Wireshark website. You'll start it up and you'll see a screen that looks something like this. So we're going to do a capture. Down at the bottom, it'll list all the network connections that you have. So I'm going to do a capture from my Ethernet adapter. Here we go. And I'm going to see a whole lot of stuff going on. So the screen is divided into 3 sections here. The top section is showing me each packet of data. On the network, data is divided up into chunks called packets. So this is each and every chunk that my computer is receiving. And this works the same way whether you're on a lighting network doing ACN. It works the same if you're on your office network checking your email. All the same kind of stuff happening. So list of packets up at the top. You can see each one has a time, and a source and a destination, where it's coming from, where it's going to. Down at the middle section, I can drill a bit more into some of these packets. So I'm going to stop this capture now. So there's a stop button up on the top left here. And one of the things, if you end up working with us on any kind of really complex problems, we might actually ask for a Wireshark capture of the problem. So what this is doing is this is grabbing data and it's saving it. You can now save this into a file, which we might have you send to us so that we can look into the details of the problem more and see each and every packet of data exactly when it happened. So I'm going to select one of these packets. I'm going to choose, say, this one right here. And let's do this one. So when I select them, you can see there's stuff is changing down at the bottom. So this bottom section is showing you the completely raw data, what's in the packet. Unless you're super nerdy, it's pretty hard to read that. It's not terribly enjoyable. So the middle section does some dissection for you. It kind of pulls that packet apart and shows you what's in it. And all of these network protocols kind of work in layers. There's a layer for the Ethernet part, there's a layer for the IP part, and there's a layer for the actual data part. So you can see this is an Ethernet packet that's being sent by something made by Dell, which happens to be my computer, which is going to a multicast. It's being sent out to a group. And we can drill further down in here and actually see the individual DMX levels. So this is part of my fade that's running, and it was sending a DMX level of 43 to everything. So it's not super often that you need to use a tool like this, but it is nice because it gives you visibility all the way down to what's actually happening right there on the network wire. So useful tool to have around just in case you ever need it. So let's talk about what else we might do on the network. So we've talked about streaming ACN a whole lot. Triggers and show control is what we're going to look at next. And that's some of what you saw yesterday with Jason and Jake and those guys. You can configure things. So we have an application called Concert that you saw a bit earlier in the week that allows you to set things up. And you can do feedback, RDM and error reporting. And you can update things. So there's a program called Updaterator, which allows you to do firmware updates to your file. So a whole lot of stuff that you can do over the network. Oh, yes, of course. I understand that would be annoying. There we go. And as we do that, we'll see my RPU takes control back over and... No. Maybe. Yeah, I stopped the source, so it should. We'll leave it a minute. It may be holding last look. It's not fading anyway. So, show control. Some of the things we saw yesterday. We want to integrate a whole lot of things, and some of these things are really great for talking to all kinds of things. So, for example, video projectors often now have some kind of UDP string interface. OSC, like you saw yesterday, you can use to tie QLab into your lighting system so you can fire sound cues or vice versa. And we've even got some things which are not network-based, like MIDI and SMPTE are physically different signals, but we have gateways to translate between those things. So this is something that Jake mentioned briefly yesterday. Again, it's a really good place to look for some of the things. ETC Labs. So this is our GitHub site where nerdy people like me who make fun tools in their spare time that are not really ETC affiliated. They're not supported by ETC, so don't call phone support. They won't help you out with these things. But it's a place where we dump kind of useful tools, interesting stuff like this. So a couple of the tools I'm about to show you are available right there on the ETC Labs site. So let's start with UDP strings. So all a UDP string is a chunk of data. I'm going to take one of those packets. I'm just going to put some stuff in it. I'm going to type some words into it, and I'm going to send it off. Very, very simple, about as simple as it gets. And we have a tool up there on the lab site called String Theory. String Theory allows you to send these kind of UDP strings in a very simple way. So I'm going to demonstrate one of those with the aid of, as far as I know, the world's only Little Einstein's UDP-controlled piano. So this is a $2.99 from St. Vinny's purchase, which is wired in to an I/O gateway. So let's see if we can make this work. So I'm going to start up String Theory. So here we go. So this is String Theory. This is what it looks like. and it just offers a very simple way to send a UDP string. So I've entered the IP address of my gateway and the port. So remember, when you're talking on a network, you're always talking kind of into a port. And these are both things that you set up on the gateway in concert. And I'm going to send it a string. So I'm going to send it the string power.
Time to play the piano. Touch a button to begin.
There we go. Okay, so I have turned on the power to the piano. This is incredibly annoying, so I'm going to turn it off. But I'm going to show you how you would diagnose some of this stuff using Wireshark as well. So we're going to start capturing. And now I'm going to turn the power off before that drives everybody insane.
Bye-bye.
There we go. All right, so in a real scenario, you might be sending UDP packets to something and it's not doing what you expect it to do. So how do you troubleshoot that? Well, Wireshark is a great way to do that. You can see that there's a whole lot of stuff in my Wireshark capture here. So when did I send that UDP command? I'm not quite sure, it's somewhere in here. One of the great features in here is filtering. So I sent that to my IP address. There's my IP address of my piano. So what I can do is I can say ip.addr is equal to that. So that really filtered down my list, and there I can see my UDP packet. So if you've got too much stuff in Wireshark, filtering is your friend. And now I can see right there, hey, I sent 6 bytes of data right there, which was the word power, which turned on the power to the piano. So that's string theory. Useful little tool for testing out this kind of thing, available from the ETC Labs site. So UDP strings are good, but one of the problems with them is their UDP means the unreliable datagram protocol. It might get there, it might not. Most of the time it's reliable enough for basic integration, but be a little cautious of using it for anything that's super show critical. So if you want something that's a better way of controlling things, you can use OSC, Open Sound Control. So this is a protocol that originally came from the sound industry, but we've adopted for a lot of lighting things, and it's great for integrating things together, things like QLab plus EOS, as you saw yesterday. And really, it's a lot like a UDP string, except there's a little more structure around it. So an OSC command consists of what's called the address pattern, so it might be EOS key go. And then you can feed in arguments, bits of data that go along with it. So again, on ETC Labs, we have a program called OSC Tester. Tests OSC, amazingly. Engineers are not very good at coming up with creative names for things. So let's take a look at that. So here is OSC Tester. So this can work in 2 modes. It can do TCP or UDP. And TCP, remember, is the one-to-one guaranteed delivery conversation. So it means that any messages I send are actually guaranteed to get there because there's a connection. So I'm going to fire a queue in EOS using this. All of the commands for EOS are listed in the EOS manual, and same for any of the other consoles or any other products like QLab, is they'll have a list somewhere of, here's all the things that you can do over OSC. So one of the things I can do with EOS is I can fire a queue. So that's really simple to do. It's just the path is EOS queue number fire. So when I do this, we'll jump to Q1 on my EOS over there. And you can see as this is a test tool, it's not particularly friendly, but what it does do is it gives you a breakdown, just like you'll see in Wireshark, of the exact data that's going to be sent in that packet. So again, you can kind of drill all the way down into the packet right here and see what it's going to look like. You can add arguments, you can use this to test out integration between EOS and QLab, that kind of thing. So as I mentioned, we've got gateways for some of these other things, the MIDI and SMPTE gateways. SMPTE is coming soon, MIDI is available right now. We've got gateways for contact closures, as I showed you with the piano. You can actually use these to translate stuff into network data. And one thing that's kind of interesting that a lot of people don't know about, built into these gateways is a method of translation to a string. There's a document on our website that describes how this works. But these things can send MIDI or SMPTE messages as UDP strings. So you can do some really crazy things. You can use MIDI or SMPTE to trigger contacts, to trigger all kinds of other things. There's a lot of options available for integration, and that's really something we're working on, is opening all this up so people can create crazy gadgets to make coffee and things like you saw yesterday. Briefly mentioned configuration. So our configuration is done using the Net3 concert software. Over the network, that uses a lot of ACN and some other protocols to set stuff up. So at the moment, most of that configuration stuff is still kind of proprietary, but we are beginning to work on opening that up as well, and you'll see a lot more of that in the future where we have many ways to interact with our products. So somebody asked earlier about RDM. So RDM has been pretty successful over the DMX wire, right? So you take your existing DMX wire and now you've got a tool like a DMX cat or concert or whatever you like to use that can set up the lights at the far end of the wire. And that's great because it means now my DMX wire, I can configure my lights, I can set my DMX addresses without getting out the ladder, but it ends at the end of the DMX wire. At the moment, there is no standard way to do RDM over network. Everybody's kind of done it in their own way. We've got a way of doing it over ACN. There's a way in Artnet that they do it. There's a way that MA lighting does it. None of that is compatible. It's all kind of proprietary. But RDMNet is on the way. So RDMNet is kind of like streaming ACN for RDM. You can kind of think of it that way. This is a project that's been going at ESTA for a number of years now, and we, as well as several other manufacturers, have people working on the committees that develop these standards. And it's really close. We are hoping to have the ratified version of the document around September of this year. So we're already starting work to implement this. And one of the cool things that we're doing with this is all of that code is available for free through our ETC Lab site. So the idea here is that if you're another manufacturer and you want some help putting RDMNet into your product, you can go to our lab site, you can grab the code, or you can just look at what we've done and test it out. So again, trying to be super open with all of these protocols. So the idea of RDMNet is now not only will you get your streaming ACN-like functionality of the console being able to send data and control stuff, but you'll get the RDM-like feedback. You'll get feedback from the lights themselves and through the gateways as well. So you'll be able to see an ETC gateway from an MA console, for example. You'll be able to configure the light using RDM through whoever's gateways you have available. So this is kind of our big push for the future at the moment, is to try and get that RDM-like functionality now across manufacturers. I think it'll be a really great thing. The other thing that's nice about this is, although we're calling it RDMNet, if you have a device that you want to configure in an RDM-like way and an RDM controller, they can still both be on the network. You don't have to go via a physical DMX cable. So a media server, for example, that just has a network connection, you'll be able to configure using RDMNet. So this is the big thing we're working on for the future in networking. We're very excited about it. We're really hopeful this will improve interoperability across the board, because that is obviously what everybody wants. And it also should be quite simple to interact with this. So again, there'll be some possibilities for people to do cool stuff that we haven't thought of yet using RDMNet. So that's where we're going in the future. I think there's a pretty bright future for networking. It's enabled some really, really cool stuff. I was at the National Theatre earlier this year and saw a production where they were using a combination of OSC, EOS, some custom-written software, and streaming ACN to allow live tracking of a rotating revolve that also rose up and down, and it was completely amazing what they'd achieved there. So that's the kind of thing that we're now able to do. So it's an exciting time. Thank you all very much. Any networking questions that we want to talk about? No? Everybody's happy. Yes?
Is show control like a Radio Shack project box that you plug into things, and how do you access it from your light?
Sure. So the question is kind of, what is show control, really? Right. So show control is kind of an umbrella term that we use. So you've got what I would call like live or streaming control. So that's what DMX is. That's what streaming ACN is. It's things that are more or less continuously happening. I want to be able to turn the encoder and my light should pan totally smoothly. So that communication from the control desk to the light is what I call the live or the streaming control. Show control is more things triggering other things, is as broad as I would put it. So it could be that you've gone to Radio Shack and built yourself a crazy box that does something, or it could be there's no additional gear at all. For example, if I just plug EOS and QLab into the same network, have EOS trigger some cues in QLab, that's show control. It's integration of show systems. It's kind of a vague term, but that's kind of how I would define it. Does that kind of make sense?
So yeah, it's not a special thing to buy from EDC.
No, it's not a thing. It's a thing that you do, I would say. Yeah, it's a concept. If you're hooking things from fairly disparate systems like lighting and sound or lighting and rigging together, that's kind of what I'd call show control.
So it's a program.
Think of it as a verb rather than a noun. It's a thing that happens versus a thing that you hold in your hand. So it's just describing that.
It's allowing things that aren't necessarily intended to work together.
That's right. Yeah, it's.
There's bits and pieces of hardware that you need to enable that communication, but the show control process is getting these devices to communicate with each other in ways that they will not necessarily.
Yep. Absolutely. So it's not a very good show, but it's a show. Cool. All right. Any other questions? Yes.
Is there a completely network-based timecode system?
Good question. Is there a completely network-based timecode system? So timecode is kind of a funny thing. The history of timecode comes very much from film and video. The SMPTE, for example, that we talked about a bit, the SMPTE gateway. SMPTE is an audio signal. There is a very new standard from the motion picture industry for a fully networked timecode, but it's extremely complex, and we're not using that in the lighting industry, and we might never do that because it's really complex and really very, very geared towards film and video. So at the moment, what we do is we transport SMPTE over the network in ACN packets, and the upcoming SMPTE gateway will have a simple UDP way of transporting the SMPTE timecode. So the answer is no, there isn't really a standard for timecode as such. And for our industry, we're working on some stuff that's kind of a very simple way to transport it around.
So for the near future, it's going to be from widget to widget with various
Yes, that's right. So there isn't kind of a manufacturer interoperable kind of standard for doing timecode at the moment. There is more of a standard for MIDI over the network. So one of the things we're looking at is actually, and you can run timecode as SMPTE timecode or MIDI timecode. So one of the things our widgets will be doing is kind of translating that SMPTE to MIDI. So then you will be able to treat it like MIDI timecode from then on, which is more standardized over the network. So that should help with that. Any other network questions? Yes? Oh, that's an interesting question. Is DMX ever really going to go away? Of course, that's a personal opinion. My personal opinion is no, because DMX connectors are really robust. Network connectors are not. DMX runs in a daisy chain, which is very convenient if you're trying to run things along a pipe. Network does not. So no, I don't personally think DMX ever will. I think it'll evolve. And Esther are beginning to look at the new generations of control protocols across the board, including network. And there might be something new that runs over DMX cable that can do more, but I think the cable, the infrastructure would still remain the same because there's so much of it out there. So yeah, the future is really interesting. You know, DMX has been around since the 80s. It's pretty antique by modern standards, so that is one of the things Esther is looking at, is what can we do to update it without having to throw away all the cable. And I would say if anybody's excited about that stuff, the Esther TSP programs are all run by volunteers, And something we've been fighting is a lot of companies send their engineers to it who are good engineers but don't necessarily have experience coiling cables or driving over things with trucks. So if any of you guys are interested in being involved, definitely contact Esther. They're always looking for people to join in those groups. They meet a couple of times a year, usually around LDI, and it's a great way to interact with other people in the industry. So, yeah.
Just on the topic of Esther, I can see where standards are good and bad for manufacturers in the sense that if everything's standardized, then everything can play nicely together, but from a manufacturing point of view, you're getting away from proprietary systems.
Yep. Yeah, no, absolutely. That's an interesting thing as a manufacturer. Yeah, the question was about how, although the good and the bad of standards is they allow everything to interoperate. So, you know, for example, when we do DMNet, you might all decide to go and buy pathway gateways instead of our gateways. I think the way we see it is, you know, some of us are old enough to remember the world before DMX, and it was painful. You had to have funny converter boxes. As a user, the experience was just not very good. So I think at the end of the day, if we can make the experience for all of our users better, that's great. And then we can also focus on adding the things into our products that make it really great. So it's not to say that we won't have extensions to some of these things, right? Like the per address priority and streaming ACN, which is our extension that our users asked for, and we said, okay, we're going to do it. So it'll still work with the basics of stuff, but we're going to give you a bit more. So I'd say that's kind of how we see that problem. Another question.
When you were talking through either the string theory or the OSC tester, you were talking about ports.
Yeah.
How do you determine that side of the system?
Sure. So the question was how do ports get determined in a network system? So a port you can kind of think of like an address in an apartment building. So great, I'm sending a chunk of data over to my I/O gateway, but there are multiple apartments in the building. Which one is it going to? For some things, it's predetermined. So for example, when you browse the web on your computer, you're always using port 80. For other things, and a lot of things we do, it's configurable. So for example, in EOS, you can set the port it's going to listen for OSC on. For the I/O gateway, you can set the port it's going to listen for UDP commands on. So it's just kind of a pre-agreed thing, and you need to make sure it matches across the board. And again, if you don't have things matching and things don't work, you can look in Wireshark and you can see, oh, this is being sent to port, 800, and it should be going to 801, that kind of stuff. So yeah, pre-agreed thing in most cases. Any other questions? Yes, sir.
So looking ahead at DMNet,
Mm-hmm.
as far as ETC products, I guess what I'm trying to say is, will products need to be updated on a merely software standpoint, or is it hardware? What are we looking at?
Sure. Yeah, so the question was, as we move into this world of RDMNet, how do I deal with product updates? Is it new hardware or is it software updates? So we are planning to do this as software updates. Of course, we won't have everything done at the exact same time, so you'll probably see a rolling kind of program of software updates. But our plan is for it to be purely software, that you won't have to swap out any hardware. Obviously, if you have some of our very old stuff, like Net2 nodes, we're probably not going to update, for example. But all of the recent gateways, all that kind of stuff, we're just planning to do software updates to add that feature in. So we certainly know that in order to get more traction on this, everybody's got existing inventory of stuff, so we always try and update rather than make you throw things away and get a new one.
And
Yeah.
everything on the DMX side of things still has to be standard old RDM compliant.
Yes, that's right. So yeah, if you're dealing with DMX wiring, as always with RDM, the DMX wiring has to be good. Don't use microphone cable. Make sure it's terminated. All of those same rules apply. Excellent. One more question. Go ahead.
You talked about a new version of Artnet. Will it make streaming ACN obsolete?
No, it's actually kind of the other way around. So Artnet is a public but not free protocol. So if you go to Artistic Licenses website, you can download and read the documents for it, but it still belongs to them, and if they wanted to change it or get rid of it, delete it, they could. It's actually the other way around. The latest version of Artnet basically says you can pick one of two ways to transport DMX in an Artnet system. You can use the traditional Artnet way of doing it, or you can just do streaming ACN. So really, Artnet has kind of just expanded to say, yeah, you can use streaming ACN as well in an Artnet system. Great. All right, well, thanks, everybody. As a reminder, if you're working on ETCP, don't forget to come and sign the sheet. Otherwise, I'll be hanging out, and I'll be free to answer any more questions you might have. Thank you. Oh, good. Glad you got a pen.